Okay, so today we're going to review some basic integration rules, so kind of a refresher of all the stuff that we've done so far this semester. So we're going to be comparing three similar integrals. So this first one for part A, we have to find the integral of 4 over x squared plus 9 dx. So I'm going to let u equal x and a equal 3, because u squared then would be x squared and a squared would be 3 squared. So I'm recognizing this as one of the arc functions. So when I look at this and I substitute that in, I get 4 over u squared plus a squared. Oops, and du would be just dx, the same thing as dx. So if you remember, this is your arctangent function with this 4 as a constant. So I'm going to leave the 4 out front, and I take that times my 1 over a, which is 3, arctangent of u over a, so it would be x over 3. And then we have plus c. So if I multiply that together, that gives me a 4/3 arctangent of x over 3 plus c. So then for part B, this time we have to find the integral of 4x over x squared plus 9 dx. So I'm noticing that this is very similar to the last problem that we did. The only difference is they added this x in the numerator. So I can no longer use my arc functions when I do my anti-differentiation here. This time when I pick my u, I'm going to let u be the whole denominator, so that's our x squared plus 9. And so then du would wind up being 2x dx. So I'm noticing I have a 4x in the numerator, so when I go to substitute this in, I can take that 4x and make it 2 times 2x. So therefore my 2x dx is here. And so I just have that 2 left over in the numerator. So I have 2 over u du. So then when I go to anti-differentiate this, I get 2 times the natural log of the absolute value of u plus c. And then I go substitute in my u value, which was x squared plus 9. So for my final answer, I get 2 times the natural log of the absolute value of x squared plus 9 plus c. So then for part C, this time I'm supposed to find the integral of 4x squared over x squared plus 9 dx. And I'm noticing that this time they added another x to my numerator. So I have 4x squared over x squared plus 9. So I can't use my arctangent stuff, and I can't use my straight u substitution at this point in time. So I'm going to have to do my long division, since the exponents are the same in both the numerator and the denominator. So x squared goes into 4x squared 4 times. So now I take 4 times x squared and 4 times 9. And then I change my sign so I can subtract. So these cancel out and we're left with negative 36. So I have minus 36 over x squared plus 9. So this integral is really the integral of 4 dx minus the integral of 36 over x squared plus 9 dx. So I can split that integral up. So now when I go to anti-differentiate, the integral of 4 dx would just be 4x. And then when I go to integrate this second integral, this is where I let my u be x. My a would be 3. So I'd have the integral of 36 over u squared plus a squared du. because du is the same thing as dx. So this is my arctangent function with this 36 as a constant. So I have 36 times, and then I have 1 over a, which was 3, times the arctangent of u over a, so that would be x over 3, then I have plus c. So I get 4x minus, and then 36 times 1/3 is 12, arctangent of x over 3 plus c. So now for example 2, we are supposed to evaluate the integral from 0 to 1 of x plus 3 over the square root of 4 minus x squared dx. So now looking at this one, if I would try and let u just be the 4 minus x squared, that doesn't match my numerator, so that doesn't make it very pretty. So the other thing that I would immediately do right off the bat here is I would try and split this up. So I would get the integral from 0 to 1 of 4 of x over the square root of 4 minus x squared dx, plus the integral from 0 to 1 of 3 over the square root of 4 minus x squared dx. So then when I go through and pick my u here to be 4 minus x squared, then du would wind up being negative 2x dx. So I'm close to matching that numerator. I'm just a constant off. So I'll use negative 1/2 du to substitute in place of that x dx. So I can't use the 0 to 1 anymore because I'm in terms of u. So I'm going to find out what those values would be. So if I plug in 0, I get 4. And when I plug in 1, I get 3. So really this goes from 4 to 3 of negative 1/2 times 1 over the square root of u du. So remember, since my integration values the smaller numbers on top, I can flip that over and make this a negative. Well, since it's already a negative, when I flip it over, it'll make it a positive. So I get 1/2, and then I'm going to write this 1 over the square root of u as u to the negative 1/2 to make it easier to use my general power rule to anti-differentiate that. So if I anti-differentiate just that part, I would get u to the 1/2 power, and I have to evaluate this from 3 to 4. So I get the square root of 4 minus the square root of 3. So this is really 2 minus the square root of 3. Then I would go back and do the other part. So if I would let a be 2, and u would be x, so du would wind up being dx, then I'd get plus my integral from 0 to 1 of 3 over the square root of a squared minus u squared du. So I'm recognizing that as an arcsine function. So I get plus, this 3 is a constant here, so I leave the 3 out front. And I get the arcsine of u, which is x, over a, which is 2. I have to evaluate this from 0 to 1. So I'll take the arc sine of 1/2 minus the arc sine of 0. And the arc sine of 1/2 is pi over 2. Pi over 6. Minus the arc sine of 0 is 0. So 3 times pi over 6 is pi over 2. So I get 2 minus root 3 plus pi over 2. Or if you get a decimal, that would be about 1.839. All right, so now I'm going to move on to example 3. So for example 3, we're supposed to find the integral of x squared over the square root of 16 minus x to the 6th dx. So I'm looking at this, and if I would let my u be the 16 minus x to the 6th, when I do my du, I'd have a negative 6x to the 5th, which doesn't match this x squared in the numerator. But if I let my a be 4 and my u be like x cubed, then when I do du, this would be a 3x squared, which is close. So I would really have a 1/3 du to get my x squared dx. So when I substitute that in, I'd have my integral of 1/3 times 1 over the square root of a squared minus u squared du, which is my arc sine formula. So I keep this 1/3 as my constant out front, and then my integral of 1 over the square root of a squared minus u squared is arc sine of u over a, and u was x cubed, and a was 4. And then I just have plus c. So I'd have my 1/3 arc sine of x cubed over 4 plus c as my final answer. All right, so we will finish notes on Monday.